So do you think I could teach all day like this? Being Mickey? Oh, hi there, fourth graders. How are you doing? Are you doing good? It's Tuesday. It's math time. MICKEYMOUSE. Math time. Wah, wah. Math time. Wah, wah. Okay, you know Miss Taylor's just corny, and it is Tuesday, and we are going to complete lesson 76. So you would have finished Power Up, the lesson practice. We did that together. Then you would have completed those division problems. Can we go over those division problems real quick? I'm just going to give you the answer. If you got it wrong, mark it so you can go back and redo it. So number 19, you should have gotten 145. For number 20, you should have gotten 123 with a remainder of 6. On number 21, you should have gotten $2.73. On number 22, you should have gotten 75 with a remainder of 3. On 23, you should have gotten 135 with a remainder of 3. And on number 24, you should have gotten 0.59. You put the dollar sign, the 0.59 cents. Yeah? All right. So let's look at number 1, and we'll just go through them fairly, hopefully fairly quick. Some of this are half of its review of problems we've already done before, but we'll just need to, go through it and see. So number 1 says Brett can type at a rate of 25 words per minute. At that rate, how many words can he type in 5 minutes? Make a table to solve this problem. Well, remember we were making tables before we even left, and we don't necessarily have to make the table except that it asks us to, and so we're going to do that. Right, John Mark? Yes, Miss Taylor. So we're going to make a chart, and it says that he can write or type in minutes. So in 1 minute, he can type 25 words. You can do it the opposite way as well. I just did it this way. So they want to know in 2 minutes, how much? Yeah. 3 minutes? Yeah. 4 minutes? Yeah. Okay. How many can he type in 5 minutes? What is 5 times 25? What if you have 5 quarters? How much money do you have? Dun, dun, dun. So he can type 125 words in 5 minutes. Now, I want you to go back through and fill out that table. 2 minutes is 50 words. 3 minutes is, yeah, there you go. You got it. All right. So number 2, we're going to call her Shake. So Shake has 5 days to read a 200-page book. If she wants to read the same number of pages each day, how many pages should she read? So she's got 5 days to read a book that's 200 pages. So she wants to kind of even it out. So what will we do? We're going to divide 5 into 200. Now, we could do that in our brains, but for our think cloud, we'll do this. 5 goes into 20 4 times. 5 times 4 is 20. When I subtract, I get goose egg. Bring down my other goose egg. 5 goes into goose egg times. So how many pages will she be reading every day? So you would say, this is number 2 we're working on, 40 pages for 5 days. She needs to finish the whole book. Oh, Miss Taylor, I think I get it. It's early in the morning, but I think I get it. All right. So let's look at number 3. Jay ordered a book for $6.99, a dictionary for $8.99, and a set of maps for $5.99. Estimate the price for the 3 items. Then find the actual price. Man, that's like double the work, isn't it? But let's do the estimating first. All right, $6.99, when I round that, it would be Yes, $7. All right. And then $8.99 when I round that, $9. And then the maps, $5.99 would be $6. Well, that's kind of easy. So we're going to add this, right? So 9 plus 7 is 16. 16 plus 6. 16 plus 6. You got it? Yes, $22. Wanted to make sure I was right. That's my estimation. Now here's a thought. Then they want you to do the actual. Well, we know that every one of these was $6.99. That's 1 penny away. $8.99. That's 2 pennies away. And $5.99. Well, that's 3 pennies away. So what's 3 cents minus 22? That's the actual price. You guys are smart like that. Good job. All right, number 4. Patrick practiced the harmonica for 7 weeks before his recital. Poor Patrick's mama. There's no telling what that sounded like at the house. Or the dog. Can you imagine a poor dog listening to that? 7 weeks of practice. How many days are equal to 7 weeks? Come on. So there's 7 days in each week. That's right. 7 days times 7 weeks would make it 49 days of listening to the harmonica. Oh my goodness, oh my goodness. Please, Patrick, put the harmonica down. All right, so you know that it would be 49 days. Number 5, 1/3 of the books were placed on the first shelf. What fraction of the books were not placed on the first shelf? Think about this, people. I have a set of books, and I put them in groups of 3. 1/3, 1/3, 1/3. 1/3 of the books goes on the first shelf. Well, how many sets do I have over here? 2/3. So the question is asking how many books were not placed on the first shelf? And you would tell me 2/3. Boom. All right, number 6. To what decimal point is this arrow pointing? What is the mixed number? This is going to be so hard to try to show on the video. But if I look at 1.5 and then I go all the way down to 1.6, so I've got my number line like this. Okay. And I'm going to count in between there so that I know what base I'm on. Because it says decimal, I'm thinking 10, but let's just make sure. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be 1.5, then 1.51, 1.52, 1.53, 1.54, 56, 57, 58, 59. Did I do it right? Okay, so they literally have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. This is 1.51. So this would be 50. That's 51. That's 52. So what would this one be? It would be 0.53. So the question is, to what decimal number is the arrow pointing? Well, it's pointing at 1.53. Because see, here is a given and I know that it's a whole number plus a decimal or fraction. Same with this. So I know it went 0.10 between the two known factors. So by doing that, I know that I am at 1.53. The next question is to ask, they want it as a mixed number, which is a fraction. So my 1 is the same. It's whole. It's always a whole number. We can't change the value. That is what it is. But I read this as 1 and 53 hundredths. So that is your answer. You think you got that? A little confusing, but I think you can understand when you find a point on the number line, we count it out, and then we just use logic. If I have 1.53, that's $1.53. Okay, so $1 is a whole dollar. 53, it's 53 pennies out of 100. It's 53 hundredths. So this is 1 and 53 over 100. Good job. We can even put a little equal sign there. All right. What is that marker doing? Okay. Good. Okay, so we've completed 1 through 6. And number 7, in the word hippopotami, not hippopotamus, but hippopotami, what fraction of the letters are the letter P? Okay. Now, what's our whole word? Hippopotami. So how many letters are in the word? 2, 4, 6, 8, 10, 11. Okay, I count 11 letters. So that's my denominator. That's my whole word. But now they're wanting to know what's the fraction of the letter P in that 11 letter word. 1, 2, 3. I see 3 P's. What do you see? So your answer would be 3 11ths. 3 11ths. All right. So we're going to say D ran a 5-kilometer race. 5 kilometers is how many meters? Remember, kilo means 1,000. So he ran 5 kilometers. So how many meters is that? 5 times 1,000. So it would be 5,000 meters. So 5 kilometers is equal to 5,000 meters. We remember what those prefixes mean. Kilo means 1,000. So if I have 1 kilometer, I know it's equal to 1,000 meters. Let's try 1,000. So if I have 5 kilometers, it means I didn't run it, I promise you. 5,000 meters. Good? Okay. What is the perimeter of this triangle? So they give us a triangle, and it's 15 millimeters on one side, 20 millimeters on the second side, and 25 millimeters on the third side. The perimeter is the distance around an object, so we're going to go around. Poor old Rover doesn't get a normal backyard, he gets a triangle. And so as he's traveling, okay, 20 plus 25 is 45. 45 plus 15, 60 millimeters. 60 millimeters. All right, number 10. They want us to estimate, so let's put our little thinking caps on here. 117 students attend 6 different grades at this small elementary school. About the same number of students attend each grade. What is a reasonable estimate of the number of students in each grade? So if I have 117 students, what could I round that up to? Well, let's make it to the tens. So if I have 117 students and I want to estimate, I would say 120. I wouldn't reduce it because there's 17 kids there. So I would make it into 120. And it says that there are 6 different grades. So you're going to do 6 into 120 as an estimating. Well, we know that. That's pretty easy, right? 6 goes into 12 2 times. 2 times 6 is 12. When I subtract, I get 0. Goose egg there. Bring down my other zeros. 6 goes into 0, 0 times. So about how many students are in each class? 20. So you would say 20 students per class. Got it? All right. So let's go to number 11. It says the length of this segment AB is 3.6. The length of AC is 11.8. So what is the length of the segment BC? Write and solve the decimal addition equation and a decimal subtraction equation. All right. So you've got this one line, really long line. You know 2 factors on it, but not all 3. So we have point A here, point B, yeah, I'd say about right there, and then C over there. Let's see if I can connect my dots. All right, so you've drawn a line similar that's in your book, and it's asking us AB is equal to 3.6 centimeters. Then it tells us that AC, so this is AB, but AC is equal to 11.8 centimeters. So I know 2 factors. I know this little measurement right here, and I know the measurement of the entire line segment. They want us to figure out, well, what is it from here to here? Well, what could I do? Well, I know the full length. So if line segment A to C is 11.8 and A to B is 3.6, well, all I'm going to do is what? Subtract from the main, right? So if I have 11.8 minus 3.6, what is the important part of adding and subtracting by decimals? Zane, Mickey says to keep the decimals lined up. Yes, keep them lined up. Got it? See it? Okay, subtract. Can I subtract 6 from 8? Yes, it's going to give me 2. Can I subtract 3 from 1? No. So now I have to borrow. 11 minus 3 is 8. So what is line segment BC? Are you with me? Is 8.2 centimeters. Good answer. Good answer, good answer, good answer. Good job. All right, now, the next couple of ones are just computation. Let's look at, and I will maybe talk you through it, but I am not going to give you the answer for it. I want you to work on this. You're smart, and I know you can do this, okay? So I am looking at number 12, and it has $25 minus, and then it has in parentheses, $19.71 plus 98 cents. Okay, please excuse my dear Aunt Sally. She's nuts, okay? Parentheses first. So I'm going to take $19.71 and I'm going to add 0.98 to that. Once I've added that together, Then I'll do the next function, which is subtract from 25. Now what they're doing is they're giving you a whole number, but isn't 25 the same as 25.00? Of course it is. It just allows us to do what we need to. It doesn't change the value at all. So I have $25.00 minus what you added together. And there's your answer. Don't forget the decimal. Keep them lined up and put that dollar sign. Okay. Now, number 13, I don't know why they do this, but it's easy. I want us to do it together. Number 13, while I'm writing this, you're figuring out, you're adding and subtracting the last one, right? Okay. So I have an equation here, and I have 12 plus 13 plus 5 plus my unknown factor that my variable is in, and it's the same as 9 times 8. What's 9 times 8? 72. Good answer there, Ray. All right. Now, I got a couple things I need to do, but that was easy. The next thing is I'm just going to add 12 plus 13. That's going to give me 25, right? 25 plus 5 is going to give me 30. So I have 30 plus n equals 72. Well, now that's a little bit easier to work, isn't it? Okay, so I know the opposite of adding is subtracting, and I need to get n all by himself. I'm going to come over here and I'm going to subtract 30 from the left side of my equation, and then I've got to come over to my right side and subtract 30 as well. So I'm going to say 30 plus n minus 30. That's just going to give me good old n. It cancels that out. And now I have 72 minus 30. So when I subtract, I should get 42. Am I right? The book says I'm right. I'm right. How can I check this, Violet? You're like, Miss Taylor, I did all this work. I don't care. I don't want to check it. Yeah, you do. So n is 42. So I can go back up in this equation and I can put 42 in its place because I just solved it. So yes, that's my answer. I can come up here. All right, 12 plus 13 is 25 plus another 5. 25 plus 5, 30 plus 42. 30 plus 42, 72. Well, isn't that what this is? Yes. So bottom line, I have 72 equals 72, and I know I did it correct. Good answer, good answer, good answer. All right, so then you have subtracting with decimals, you have multiplying with multiple digits, and then if we go down to number 25, n plus 6 equals 120. It was the opposite of adding, subtracting. So if I subtract 6 from one side, I'm going to subtract it from the other side. So bottom line is n is equal to 120 minus 6. What is that? 26. 4w equals 132. We know that 4 or any digit next to a variable, if they're next to each other with no sign, it means they're multiplying. What's the opposite of multiplying? Yes, it's dividing. So I'm going to divide 4w by 4. Then I want to go over to the next side, the right side, and I'm going to say 132 divided by 4. So 132 divided by 4. 4 goes into 13 3 times, because 3 times 4 is 12. I subtract, and I'm going to get 1, and I'm going to bring down my 2. 4 goes into 12 3 times. 3 times 4 is 12. So my answer would be 33. job, good job. Now, there are, what is left? I may have to stop this video. I'm afraid it's not gonna, it'll be too long. How about I will do 27 through 30 on the language video, so this isn't too terribly long. Thank you.